Hi. In this question, we are going to look at a recurrence sort of relation, and we want to understand how the properties of this xn term can be defined by conditions on the initial variables. So we have let x1, x2, x3, which is a sequence of non-zero real numbers satisfying this condition. Xn is equal to x of n minus 2 minus x of n minus 1 divided by 2x of n minus 2 minus x of n minus 1. And this relation is valid for n goes from 3 to 4, 5 and onwards. We are asked what are the conditions on x1 and x2 such that xn is an integer for infinitely many values of n. So xn is an integer for infinitely many values of n. Now, the first thing that you see when you have a problem like this is possibly try to simplify this expression a little bit. So I also tried to simplify it and I took a reciprocal of xn and I wrote it like this, divided by x of n minus 2. Actually, I made a mistake in writing it here. This is a product on top and this is a subtraction. So x of n minus 2 into x of n minus 1. When I take reciprocals, this is what I get, right? So if you simplify it a little bit here, you will realize that 1 by xn is equal to 2 by x of n minus 1 minus 1 by x of n minus 2, which looks like this. 1 by xn plus 1 by x of n minus 2 is equal to 2 by x n minus 1. Now, this type of relation is familiar to many students. This is obviously an AP in the reciprocal. So basically, this is a harmonic progression. So you can say that actually 1 by xn minus xn, 1 by xn minus 1 and 1 by xn minus 2. These are in HP, right? So this is an HP and x1, x2, x3 and all will satisfy this HP sort of a relationship, right? Now, I did this, but after this point, it is difficult to come up with a condition such that xn is always an integer. Like HP doesn't actually give us too many conditions. There is no general formula for an HP nth term. I mean, you can find it using the AP, but you feel like there is no way to progress here, right? This is interesting, but it doesn't lead to a solution. So what do I do now? So one common problem solving strategy that everyone should be aware of is searching for a pattern. So I have already found one pattern, but this pattern is not helping me much because the question is trying to say that xn should be an integer for infinitely many values of n. So since this pattern is not working, I'll try something else now. So I'll write this again, xn is equal to xn minus 2 multiplied by xn minus 1 divided by 2xn minus 2 minus x of n minus 1. And I will try to look at smaller cases and evaluate some small cases and then try to see if I can notice some pattern, right? So let's put n is equal to 3 because that is the starting point here. If I put n is equal to 3, I get x3 is equal to x1, x2 by 2x1 minus x2, right? Okay, we have to evaluate a few more cases to be able to come up with anything concrete. X4, let's calculate x4. So x4 should be x2, x3 by 2x2 minus x3. Now, here we can use x3 from here and we'll say x2 into x1, x2 by 2x1 minus x2 divided by 2x2 minus x1, x2 by 2x1 minus x2, right? If you simplify this a little bit, you will eventually get, after cancellations and all, x2 can get cancelled from the top and the bottom, and then you simplify it again, you will eventually end up getting something like this, x1, x2 by 3x1 minus 2x2. So this is what is coming as x4. And if you see, x3 was like this. So we are beginning to see a pattern here. And if you evaluate x5, you will again get x1, x2 by 4x1 minus 3x2. So again, this is after a little bit of computation. You have to calculate this, you have to calculate this, and you have to calculate this, and then you can see that there is a clear pattern. So you can predict that xn should be x1, x2 by n minus 1 x1 minus n minus 2 x2, right? Once you have guessed this, the job is to prove it by induction. I will not do that proof. That proof is pretty straightforward. What you will say is, let's assume this formula is true for xn, and from this formula, try to get the formula for xn plus 1. Prove that formula, and then you will confirm by induction that this is the condition, right? So, what is the lesson that is learned here? The lesson was, in the beginning, I tried rearranging the terms and I got an HP, but that was not helping us conclude something substantial. But if you try a little more, I tried evaluating some lower cases, we are able to predict the formula for xn. So that is good. Once we have this formula, xn is equal to x1, x2 by n minus 1 x1 minus n minus 2 x2, we can rearrange it a little bit and write it like x1, x2 by x1 minus x2 can be taken common, x1 minus x2 here with n, and plus 2x2 minus x1. What have I done? I have taken all the nx1 and the nx2 together and I have written it like this. So I'm getting this condition. Now I want to make xn should be an integer for infinitely many values of n. Infinitely many values of n, right? Now you will realize that if x1 minus x2 is not equal to 0, then as n increases, the denominator of this fraction increases. And it is likely that eventually what will happen is the fraction will become less than 1, right? So think about it. If this is non-zero, then when you increase n, what will happen? This denominator becomes very large and the overall expression for xn will become less than 1, right? So it will not be an integer, So if you want to make it always an integer, maybe we should try x1 minus x2 should be 0. If x1 minus x2 is 0, you will get xn is equal to x1, x2 by 2x2 minus x1, and that will become x1 squared by x1, and that is equal to x1, right? So in that case, the xn is always equal to x1, and this condition is basically saying x1 is equal to x2. So what condition we are getting here is that if you say x1 is equal to x2, that in general, all terms of the series become equal and they are all equal to x1. So the series is simply a sequence of x1s, right? x1, 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 and so on. So there are infinitely many terms in the sequence and all of them are integers as long as you satisfy the condition x1 is equal to x2. So that is basically the solution of the problem. The problem was asking us for establishing conditions on x1 and x2 so that xn is always an integer, and we have done that here. So the key thing to keep in mind here is sometimes you have to evaluate the first few cases and try to search for a pattern. So that is what we did here, and that led to a successful solution. So that's all for this problem. We'll see more problems coming soon on the channel. So stay tuned and please like the video and subscribe to the channel. And I'll see you in the next video.